Hi, this is Katie. Welcome to Online Math Tutorials. Today's topic is reflecting functions. Reflections in functions means flipping an object over on an axis. So the reflected functions or reflected object is exactly the mirror image, for example. When you're reflecting functions, there's no rotation, no translation, and no change in size. There are three types of reflections. First, vertical reflection. We can call it VR in short form. Number two, horizontal reflection. We'll call that HR. The last one is inverse reflection. If you want, you can call it IR. But usually we use just the term inverse. We're gonna go over each type of reflection in more details. Starting with the horizontal reflection. So horizontal reflections occur when x variable is replaced with a negative sign in front of the variable x. X will be replaced with negative x. So in other words, you can think of it as x coordinates will change the sign to the opposite, but y coordinates will not be changed at all. So x and y, for example, will change to negative x and y. So let's take a look in graphical representation of a horizontal reflection using example. So here are the two functions. Y is equal to square root of x, and we're going to take a look at what happens to the function when it has negative sign in front of the x variable. Okay, we're going to see how the graph will change when they're transformed from y is equal to square root of x to y is equal to square root of negative x. So start with the table values. 0, 1, 4, 9, 16, for example. So when you take the square root of x's, like these values, the y will be just the square root of these values, which is 0, 1, 2, 3, and 4. And we're going to plot those points on the grids. So we're going to sketch the graph. So 0 and 0 over here, 1 and 1. So maybe we can line 1 and 1, 4 and 2. And obviously we can't draw, or we can't have the 9 over here, but you know the shape will be like going from 0 and 0 to continue like this. Basically that's the shape of the graph for y is equal to square root of x, and we're gonna just draw the other one using the same shape, but it will be transformed, and we'll see how the points are transformed in the second graph. So let's make a table values for the second graph. So we're gonna keep the y values the same, and we're gonna change the x value to get the same y value. So we keep the 0, 1, 2, 3, 4, but this time we're gonna find the x value when the negative sign is in front of the x variable. So to get the y as 0, the x has to be 0. To have the y as 1, so inside the square root should have a positive, so that means it will be negative 1. To make it negative, negative, positive. 2, in order to have the y as a 2, that means it will be 4. It has to be negative x has to be 4. So since there is a negative sign in front of the x, so it has to be negative 4. Same rule applies to the other numbers, other points. So it will be negative 9, negative 16, and so on. Okay, let's plot the points 0 and 0. -1 and 1, -4 and +2, so it's over here. So that means all the points on the graph will be flipped from the original points horizontally. So all the points are crossing over the y-axis. So the second graph goes like this. As you can see, the shape of the graph doesn't get changed. The size of the graph doesn't get changed. Only the points or the whole graph is flipped over the y-axis. So we can say that there was a horizontal reflection happened, which means all the points are flipped or reflected over the y-axis. Okay, so this is what happens when you have the negative sign in front of the x variable. Horizontal reflection over the y-axis. Let's move on to the second type of a reflection, which is vertical reflection. And it's VR. So vertical reflection occurs when y variable is replaced with a negative sign in front of the y variable. So y becomes -y. Only the y coordinates change sign. The x coordinates do not change at all. So the coordinates starting with x and y becomes x and -y when there is a vertical reflection happening. Okay, so let's use the example for this one, vertical reflection. So here's the two functions that we're going to compare. So y is equal to x squared, and we're going to take a look at -y x squared. Okay, so as you can see, the x squared, there's no change to the x variable, but there is change to the y variable. This time it has negative in front of the y variable. So let's draw the graph. So this is a very common graph, common function. It's called the quadratic function. Y is equal to x squared. The shape of the graph will be a parabola. So if you want, you can use the table of values to figure out which points that you have to use to draw the curve. But since it's a very common, we're just going to use the shape of the graph. Okay, so starting with the axes. So y is equal to x squared. We'll have the shape like this. It's pointing upwards, a U shape, I call. Okay, so that's the y is equal to x squared. And let's draw the second graph. But before we do that, let's change the form of the function. So we like to have just the y on the left side of the function. So we're going to remove that one to the right side of the equation. So that means the function can be written as y is, we just remove, and then to move that to the right side of the equation, -x squared. So which means the leading coefficient of this equation or function is negative instead of positive. So that means it will be an upside down U shape when you draw it. It will be upside down, same size, same shape, just flipped it over to the x-axis. As you can see, there is vertical reflection. This time is in the x-axis. Okay, before we move on to the last reflection type, I want to make a note that you have to understand the difference between the horizontal reflection and vertical reflection. Okay, so what is the difference between HR and VR, or in other words, horizontal reflection and vertical reflection? So horizontal reflection is the ones that has negative sign inside the function, which means when you have the y is equal to f of x using the function notation, and that is the original function, and horizontal reflection is happened, then the function will take the negative sign inside the function notation. So which means f of x, instead of f of x, it will be f of negative x. Like this. So this negative sign is inside the function right there. For the vertical reflection, is the opposite. The negative sign will be outside the function. F of x as the original. Vertical reflection happened. Negative goes out to the y variable. So negative y is become or equals f of x. But if you rewrite it as y is something, this negative goes to outside the f of x. So which means y is negative f of x. So this, the word or this outside is referring to the having the negative sign in outside the f of x. Right there. Let's take a look at a few more examples. Y is equal to absolute value of x. Transformed, y is equal to absolute value of negative x. We're going to identify what reflection or which if reflection is happening. So this x becomes negative x, which means negative sign is attached to the x, or negative is inside the function. So that means it's the horizontal reflection. Y is absolute value of x becomes y is negative absolute value of x. So this time the negative is outside the function, or you can call it negative is not attached to the x, and this negative can move to the y variable, and you can write it as this form, and you can see that negative is attached to the y. That means it's a vertical reflection. Y is square root of x becomes y is negative square root of negative x. This one has two negatives. This negative is attached to the x, and that negative, second negative, is outside the square root, which means it can be attached to the y. So this one has two types of reflection. So you can call it both HR and VR are happening for this example. Let's get the last example. Y is 1 over x becomes y is negative 1 over x. So this fraction can be written in two forms or three forms. Negative can be in the numerator, negative can be in the denominator, or it can be in front of the whole fraction. So you can write it as 1 over negative x, or negative of 1 over x. Two forms. If you look at the fraction as the fraction with the negative sign in the numerator, if you look at the fraction with negative sign in the denominator, which is negative x with the negative sign, then it will be horizontal reflection. But if you look at this part as a negative with sign in front of the whole function, which is 1 over x, then it can be vertical reflection. So this case, it can be either horizontal reflection or vertical reflection as the answer. Make sure you understand which reflection takes the negative sign, or where the negative sign goes in the function form. So make sure you understand negative inside the function with the negative sign. A negative sign inside the function is for horizontal reflection, and negative sign being outside the function for vertical reflection. Okay, Let's finish with the reflection with the last type, which is an inverse reflection. Some people use the inverse function for inverse reflection, so you can even call it inverse function. And there is symbol for inverse function or inverse reflection, which is this. So y is equal to f of x, transform using inverse reflection, then you can write it as f inverse of x. So you have to use this little symbol -1. So this is not an exponent. This is just a symbol for inverse function. Inverse function is a reflection over the line y equals to x. And when you're reflecting object or function over the line y equals to x, the x value and y value will be switched. So y is equal to f of x becomes x is equal to f of y. In coordinates, x and y becomes y and x. Let's take a look at one example for inverse reflection. We have a function defined as y is equal to 3x minus 5. And let's find the inverse of this function. So when you are finding inverse of a function, all you need to do is just switch the x and y in the equation, and you just need to rewrite it in y is equal to something. So all you need to do is change the x and y. So y becomes x and x becomes y. 3y minus 5. What we're gonna do is we're gonna isolate the y, which means we're gonna keep the y term alone and move everything else to the other side of the equation. We're gonna leave the 3y on the right side and get rid of this -5 by adding 5 to both sides. So this becomes x plus 5 is 3y. And let's get rid of this 3 in front of the y by dividing by 3 both sides. So it will be y is equal to x over 3 plus 5 over 3. Okay, so inverse of the y is equal to 3x minus 5 is x over 3 plus 5 over 3, or you can even use the symbol for inverse function. F of x, inverse f of x is equal to x over 3 plus 5 over 3. And that's how you write the answer for inverse function. Before we move on, I want to make a note that you have to be careful with the domain and range in inverse function. So note, domain and range. Because the reflected image or reflected function, the inverse function, is also a function, you have to define domain and range. The domain of the original function becomes the range of the inverse function. And the range of the original function becomes the domain of the inverse function. So that's the note that you have to remember. To sum up the reflections, let's summarize all types of reflections. Y is f of x, transformed y is equal to f of negative x, and that is for the horizontal reflection in y-axis. Y is f of x becomes y is negative f of x. There is a negative in front of the f of x. Then that is for vertical reflection in x-axis. The last one, y is f of x. X is equal to f of y, or in other words, y is inverse f of x, and that is for inverse reflection in the line y is equal to x. Let's try a few examples. Okay, for the following functions, let's indicate the type of a reflection, reflection for each function. So y is equal to square root of x becomes y is equal to negative square root of x. Because there is negative sign in front of the square root of x, this can be moved to in front of the y and can be written as negative y equals to square root of x. There is a negative in front of the y, where the y is changed to negative y. Vertical reflection is happening. Number 2, y is absolute value of x minus 3 transformed y is negative absolute value of x minus 3. This negative can be moved to in front of y and written as negative y is absolute value of x minus 3, which means the y becomes negative y. So it is another vertical reflection. Y is absolute value of x plus 2 transformed y is absolute value of negative x minus 2. Okay, let's distribute the negative in front of the brackets. So this becomes y is absolute value of, we're just multiplying the negative inside the brackets. So this becomes negative x plus 2. As you can see, x, there's no change to y. X becomes negative x. So which means it's the horizontal reflection. Number 4, y is 3x plus 2. Transformed, y is negative 3x plus 2. This one, you may need to manipulate the equation a little bit to see what happens to the x or y variable. What we're going to do is we're going to keep the y the same, and we're going to change the order of multiplication. So this means negative 3x means negative 1 times 3 times x. So what we're going to do is we're going to write it as 3 times negative x plus 2. What we did was we just moved the negative to inside this multiplication, 3 times x. So we can see that x is becoming to negative x. So nothing else is changed. Y becomes y, x becomes negative x. All the other numbers are kept same. So it is the horizontal reflection. Okay, one more problem. Given a and b is the point on y is equal to f of x, we're gonna find the coordinates for the corresponding transformations. So we've got y is negative f of negative x. There is negative in front of the y, or negative in front of the f of x, and there is negative in front of the x. So that means it's for horizontal reflection and vertical reflection. A and b becomes negative a and negative b. That's it for today, and thanks for watching, and see you next time.